Users could see tables they shouldn't have access to. The developer assumed a new database would create a private schema, but tables ended up in the shared public schema. Let's explore. You'll learn how Snowflake organizes data into databases, schemas, and tables, and how to choose the right data types. We'll walk through real examples and common pitfalls so you can set up your environment confidently. Snowflake organizes data in a multi-level hierarchy: account, database, schema, and table. This structure helps you manage large amounts of data, enforce security, organize work logically, and avoid naming conflicts. Let's create our first database and schema. Use create database if not exisds, and create schema if not exists to avoid errors. Then set your context with use schema and verify with current database. Here's the SQL to create a database and schema. Notice we use if not exisds to make the script idempotent. After creating, we set the context with use schema and then verify by calling current database and current schema. Tables are the core storage objects. Use create table with columns to define them, specifying names, data types, and constraints like not null and unique. AUTOINCRMENT generates unique numbers automatically for surrogate keys, and default provides default values. We create 3 tables for an e-commerce schema: customers, orders, and order items. Notice the use of AUTOINCRMENT, not null, unique, and default. The primary key and foreign key are metadata only, they aren't enforced. Snowflake supports many data types. For beginners, the numeric types integer and decimal, the string type varchar, date time types date, timestamp, and Boolean, the semi-structured type variant, and other specialized types. Choosing the right type is crucial for performance and storage. This example creates a table with various data types, including a variant column. We use parse.json to insert a JSON object, then query a nested field with the colon operator. Snowflake excels at semi-structured data like JSON. Use variant to store it, along with object and array, the colon operator to access fields, bracket notation for array indices, and flatten to expand arrays into rows. We use parse.json to store a JSON object with an array of items. We query the first product ID using bracket notation and colon operator, then use flatten to expand the array into rows. You've created your original table, but later you may need to modify it. Use alter table to add, drop, or rename columns and to change data types. The result is a modified table ready for your schema. For dropping entire tables, proceed with caution, always test in a non-production environment first. These alter table commands add a column, rename a column, change a data type, and rename a table. The drop table is commented out to avoid accidental deletion. Design your Snowflake environment properly from the start. Use separate databases for dev, test, and prod. Organize schemas by domain. Name objects consistently and add comments to help others understand the schema. This example shows a well-designed schema with comments on tables and columns. Comments are stored in information schema views and can be queried for documentation. Here's the chain reaction. The developer created tables in the default public schema, which is shared with all users who have access to the database. This made tables visible to unauthorized users. The root cause was not creating a dedicated schema for the team. The fix started with the account, then we moved to the database. We created a dedicated schema for the team, moved the tables into it using alter table, renamed to, and revoked permissions on the public schema. This makes the tables private. Now only authorized users can see them. This is the mistake from the incident. Creating a table without a schema drops it into public, visible to everyone. The fix adds a dedicated schema, my schema, so the table is restricted to your work. Always qualify your tables with a schema. Omitting length on varchar, as in the broken code, triggers a 16 MB default that wastes space. The fix, shown in the working code, is to specify an explicit length like 100, which bounds storage and prevents that overhead. Primary keys in Snowflake are metadata only, they don't enforce uniqueness, so duplicate rows slip through. Here, both inserts succeed. Switch to a unique constraint, and the second insert gets rejected, enforcing real uniqueness. To diagnose issues, first ensure you're in the right context. Use database and use schema. Check permissions with show grants. Use describe table to see column definitions and typeof to check data types. Time for common interview questions about Snowflake's hierarchy, table creation, and semi-structured data types. Let's walk through frequently asked questions about Snowflake databases, schemas, and tables. To recap, Snowflake's hierarchy helps organize data and manage permissions. Always create dedicated schemas, choose appropriate data types, and document your schema. Avoid common mistakes like using public schema or omitting varchar length. Thanks for watching. The full article and code examples are covered in detail at thecodeforge.io.